What I'm about to tell you, my friends, is just something fantastic, mystical, esoteric, and real physics that actually works. Mikhail, welcome.
Good afternoon.
Please tell us, how can a thing like this, which we simply place on an amplifier or on speakers or even on a DAC or a source, actually change the sound? Well, everyone keeps writing to me in the comments. When I was visiting Victor, he had those little Topper Yeti pyramids standing there.
Topper Yetis are everywhere. They're absolutely necessary for eliminating resonance. Never put them on the front panel, as some companies recommend put them at the back, in the center, or at the rear. Never on the front. Yes, you can, sure, yes. That is, it only removes the resonance specifically from all those front parts.
And he kept proving to everyone that if we put them on the speaker, the sound changes. Move them to the back, the sound changes again. Well, I really did hear it, and the sound does change, but most people just don't believe it. And everyone says, you guys are crazy, yeah. Let alone the basic cables, which really can improve or worsen the sound of your stereo hi-fi or high-end system. Many people don't believe that either. So, as an engineer, as a serious representative of Knecht Audio, could you please tell us why we should buy such a thing?
To improve the system.
And how does it work?
First of all, Radeon, it's not a thing, it's a damper.
Right.
A damper, and the official name is damping. This is the M model.
Medium.
Medium.
Okay.
The little pyramid also works a bit. It works sideways. It changes the resonant properties of a system and shifts the frequency elsewhere.
So
that's why the system changes a little. But the damper is designed to improve and enhance quality. What does it do? It's a purely mechanical device that absorbs vibrations from audio components through viscous friction. By absorbing vibrations, we reduce distortion in the audio signal, but in each component, vibration causes its own kind of trouble. Let's start by looking at the tone arm of a vinyl turntable.
In that case, everything is obvious.
Everything vibrates there, but you can install a small damper for it. The damping TT model, also known as TT.
No big deal, yours is made of metal.
It's shockproof, metallic, and weighs 4 grams.
So we put this thing right on the tone arm?
Right on the tone arm tube. It's secured with a small rubber band. And this damper absorbs the vibrations of the tone arm tube.
That makes sense.
Accordingly, fewer vibrations reach the cartridge and end up in our signal. That's the very first step. If we take a digital device, like a streamer or a DAC,
what could there be in that case? I can understand with a CD player, yes, there are those vibrations, but what about a streamer or a DAC?
In a CD player, streamer, or DAC, there is a quartz frequency generator. It's a mechanical device. When an electric current is applied to the quartz plate, it starts to vibrate at the required frequency. Now imagine, you turn up the music, the chassis of your audio component starts to vibrate a little, and that vibration is transmitted to the case of the quartz frequency generator. And those vibrations affect the oscillations of the plate. And as a result, we get uneven clock timing in the digital system. This is when the first jitter appears. And errors occur during digital to analog conversion, when the shape of the signal, due to the uneven time scale, starts to compress like an accordion. And we hear noises, not just noise, but rumble. That kind of noise. These are low-level distortions that mask quiet sounds. And it's these quiet sounds that are responsible for the natural timbres of musical instruments.
Well, the so-called sound contrast.
Long reverberations.
Yes.
The piano starts to sound like wood and metal. The attack of the instruments improves, the bass becomes more articulate, and you can distinguish the components where the kick drum is, where the bass is, where the synthesizer is. This is a purely mechanical device. And if we take the example of acoustic systems...
Now that's a big damper you have there.
That is the L model, which weighs 4 kilograms. Pick it up.
All right.
Better too.
Seriously, yeah, I can really feel the weight here. It's really
4 kilograms.
Heavy duty.
It's placed on a special silicone pad, which provides a better effect than mechanical contact with the surface, right? So that it presses down as much as possible. And what happens is, in any speaker system, regardless of price, when the bass or mid-range drivers vibrate, some of those vibrations are still transmitted to the front panel. And that's where the tweeter is mounted. The tweeter's vibration amplitude is sometimes 0.7 microns, sometimes 1 micron.
Well, that's quite minimal.
But the front panel can vibrate with a much larger amplitude, and the signal gets blurred. The high frequencies become less clean. So here we're fighting to make sure the signal reaches the speakers as cleanly as possible, while in speaker systems we're fighting to make them work much more precisely. It's pure mechanics.
I agree here because in acoustics, all engineers at more or less serious companies try to isolate the tweeter as much as possible from the mid-range and especially from the bass.
Yes, to hide them in enclosures.
Exactly. Some make turbine heads like Bowers, others like KF, just try to decouple them internally. Wilson Audio also makes different enclosures. They do a great job with that. Yes, PMC follows its own path, but the idea is clear. That's it. Now I think the viewers will understand that this thing simply absorbs vibrations from the tweeter and from the mid-range.
From the whole cabinet.
It kind of absorbs them.
Absorbs them thanks to viscous friction, because there's a pendulum system inside.
I can hear it. Yes, something is rubbing in there.
And when the damper's body follows the vibrations of the component itself, friction occurs inside, and all the vibrations are converted into heat. Well, not all of them, but as much as possible.
I actually touched one of those things you have and it was really hot. Is it heating up?
That means it was vibrating really hard.
Turns out, because of the vibration,
Well, no, it doesn't really heat up. Maybe it heats up by
just a little, it was
thousandths of a degree. That's about how much energy is transferred from the vibrations. Most likely, it heats up from the radiators.
well, it was kind of warm. So that means you need to put it on the speakers, on the amplifier. By the way, how does this work with amplifiers?
Transistors are attached to each radiator mechanically with screws for clarity.
Right.
When the transistors are subjected to vibrational stress, their operating modes change. The currents start to flow differently. The gates start to operate with minor errors. It's not that the sound disappears completely, but it does get distorted. And you can hear it. That's a fact. In general, the effect of vibration on transistors is thoroughly described in the scientific literature. By attaching a damper with a clamp to the heatsink, or if the amplifier has a rigid cover, you can place a large damper, or the M model, directly on the amplifier cover, which significantly improves the amplifier's operating mode.
Very interesting. Then you should put them on everything, really.
There are clients who do in fact put them on everything, from speakers to sources.
For example, my amplifiers are placed on Tauk feet. Those are Japanese division of Toyota Corporation.
Great devices.
Yes, these are special feet. They consist of two parts. And indeed, the sound does improve. Before that, I had inacoustic ones, which were simpler.
But let me just add a little comment here, if I may. Tauk feet isolate your speakers from the floor.
Yes, absolutely right.
They prevent low-frequency noise from the floor from entering the cabinet.
That's right.
But as soon as you add sound, your speaker system itself becomes a source of vibration across a wide frequency range.
Of course, especially if it's loud, especially with strong bass and high sound pressure. Of course, in theory, I understand that this sound will, one way or another, reflect off the walls and reach the amplifier and the components, causing them to vibrate. That's partly why when we turn up the volume, so to speak, we experience some discomfort, because the amplifier also starts
And the signal distortion starts to increase.
always more.
Because of this, we tried in SAI, in systems with headphones, dampers are not always effective, since there's no loud acoustics in headphones. And if the components are good, the effect of the damper is almost unnoticeable. Well, to be honest, but as soon as you turn on the speakers, that's it.
How much does such a thing cost? It needs to be installed carefully.
The retail price of the large damper is 85.
So
The M model is 60. And the small damper for the tone arm,
let's install it.
30,000 rubles.
30,000? Well, considering how much some vinyl turntables cost these days,
How much do vinyl records cost?
yes, I think it's reasonable to install such a thing. All right. And also, people often laugh at audiophiles who put their cables on stands. What do you think about that?
Stands. Cables also experience vibrational stress. When a cable bends, its inductance changes, the conductor's properties change, and there are significant vibrations coming from the floor. And there's also a slight electrical contact between the cable and the floor. That's why it's justified. And in high-end systems, you can actually hear the effect of these cable stands.
Are you actually planning to make such cable stands? Because it seems to me that would be just perfect so that...
Knecht engineers are currently in the process of developing a specialized device that is designed to attach securely to a heavy cable located near both the speakers and the amplifier. The purpose of this device is to effectively dampen and reduce the cable's own unwanted vibrations, which can interfere with sound quality, thereby improving the overall audio experience.
All right. If someone doesn't have a lot of money but wants to buy something like this, what would you recommend they get first?
If it's a vinyl turntable, of course, the first thing to do is to put it on the tone arm.
I see.
And if it's a digital setup, then put at least one DEMPI-cam on the streamer or DAC.
That would actually be better than putting it on the amplifier or speakers.
It will be much more effective because distortions originate at the source and you need to suppress them at the source first and then move on.
Interesting.
Reduce distortions along the signal path as you go. But the main thing is to do it right at the beginning.
And how many of them should you use, Mikhail?
It all depends on the system. There are small systems like a amplifier. Just recently a customer had an amplifier with a built-in streamer and built-in DAC, an integrated unit. So one damper was enough, and his friend had a similar preamplifier with a built-in DAC and streamer, but with a Class D power amp as well. There you already need two dampers, and as the system grows, you can increase the number of dampers.
What if you cover the entire top lead with these dampers?
That won't be effective.
It won't, right?
One is enough.
Even so, right?
Because the energy feeding the vibration isn't that great. And a damper weighing 1 or 2 kilograms is more than enough to handle it.
And what if you just put some kind of weight on top? Like one of my friends said he put several dumbbells on his speakers wheel that work too.
There's this one enthusiast who puts a 40-kilogram marble slab on his Waria. He says, when I put on 60, something starts to crumple and the transport begins to jam. But 40 is just right. But he tried the damper and said it works better. When we put something on top like a slab or a dumbbell, in science this is called mass damping. First of all, the stiffness of the system, that is, the component changes, and its property, namely its resonant frequency, also changes. But the vibration doesn't disappear. The extra mass just reduces the amplitude of the vibration. But this slab does not absorb the vibration, and the system continues to vibrate. That's why adding a damper converts the vibration into heat.
So probably the ideal fit for your dampers wouldn't be TAOC, but Nordost, because they also use those decoupling balls.
But they only work in the horizontal plane.
Yes, yes.
And in the vertical direction, vibrations still pass through the board.
Well, that makes sense. And then if you put your damper on top, that would be just perfect.
Perfect heat would create a noticeable effect that helps you get the full potential out of the system.
Because I also have Nordost cones, the titanium ones, the top of the line, and they really...
They're actually called cold ray...
No.
Cold ray, yes, those titanium cones.
Nordost?
Nordost? The model is called cold ray.
Probably. And they have bronze ones too, I think. Please write in the comments what the other material is. And then there are the top tier titanium ones. And when you use the titanium ones, you really notice the differentiation, even clearer, faster sound, and the bass changes a bit. I'm sure these things will work just as well.
I suggest that people, if they wish, discuss in the comments which is better, cones, rubber isolators, air isolators, or just putting down a solid granite slab surface.
Please write in, friends. Well, this is really interesting, Mikhail. Thank you very much. And what you're doing is truly, it's like fine-tuning, creating the perfect system. But who doesn't want that, friends? Well, what can you do? I think if you put it on a JBL speaker, you probably won't notice much of a difference.
No, that one can be saved anymore.
Yes, but here, this is the ultimate kind of tuning where even a tiny improvement by fractions of a second matters. You know, like in motorsports, when you complete a lap just 10th and hundredths of a second faster.
I think it's like adding octane to the fuel.
Even like that, huh? Well then, let's give it a try. Thank you very much.
Thank you, Rodion.